Okay, for today, we are doing complex numbers. Just to clarify what a complex number is, a complex number is a number like 4 plus 3i. Why? Because it's got a real part and a not real, also known as what? Don't remember what that's called? If it has an I in it, it's an imaginary. Okay, so this has a real part, as in a real number. What's a real number? Well, it's a number that's not imaginary. And that seems like it's totally made up, but I has to do with the imaginary numbers. All right, I know you learned this in higher algebra last year. I teach that class, so I know that you learned this stuff, but it's been a long time. It comes up from this. Square root of negative 25. Do you remember that that's actually square root of negative 1 times the square root of 25? And you know that one is 5. And what's the square root of negative 1? Say it if you know it. I. All right. So this is I and this is 5. So my answer for this is 5i. Usually just put the number first. Okay. Now, what was the most important I? I squared. Because I squared was, well, it's I times I, right? And I is square root of negative 1. And by definition, when you multiply two square roots, the answer is whatever's under the root. So it's negative 1. I'll give you an example of that. Square root of 5 and the square root of 5, when you multiply them, it makes the square root of 25. So the answer is whatever's under the root. Do you get what I'm saying there? Okay, so that's why I squared, I times I. Here's I. Together they make negative 1. Why is that such a big deal? Because when you see this, and you multiply it all the way out on the ACT test, you'll know how to multiply that out. It's not a big deal. You just have an I squared in your answer, and then this is the precious big moment. You take the I squared, you pull it out, and you put in, what did we just say 2 seconds ago? I squared is equal to what? Negative 1. Do that. Multiply this thing out. It's going to have an I squared somewhere in it. Yes, it'll have some normal i's. You can't just replace normal I with anything, even though normal I is the square root of negative 1. Your answer can have i's in it. It just can't have I squareds. Otherwise, it isn't simplified all the way. All right, I'll pause while you give this one a try. Okay, you should have had 5 times 3 makes 15. And then I like to do the outside and the inside. You could do them in any order you want to, as long as you get all 4 parts, you're good. So then I have negative 5i, and on the inside I have positive 3i. And for my last, I have, careful now, negative I squared. But the I squared itself can be replaced with a what? A negative 1. So then it's negative of negative 1, which makes it positive 1. Positive 1 plus the 15 makes 16. And these guys put together makes negative 2i. And that's the right order to do it in. If you put the i's first, you lose. It's not that big of a deal. But with a complex number, which is part real and part imaginary, you put the real part first. Raise your hand if you got that. Okay, awesome. Now, all you really have to do for today is master problems like this. So let's do this one together. And this is adding complex numbers. You just multiplied them a second ago. Okay, and then we got to be able to take 1 over a complex number. And then we have to divide 2 complex numbers, z, which was this one, and w, which is that one. And I'll show you how to do that. Then you got to do this little weird line over it. All that means is conjugate. And last but not least, you take a number times its conjugate, and then hopefully that'll remind you what they're good for. All right, so the concepts I need to remind you right now is, number 1, when you put a complex number on the bottom, why is that bad? And why do we have to be careful? And number 2, what is this weird conjugate thing, and how do you use it? Okay, so do you remember problems like this? And we would multiply by its conjugate. What was the conjugate of 1 plus sine theta? 1 minus sine theta. And why would it be smart to multiply by that? Because the denominator, some of you are drifting, come back to me. The denominator now multiplies out to something cool. First outside, inside, last, and it becomes 1 squared, which is 1, minus, and the outside and inside cancel because one's positive and one's negative. It comes out to 1 minus what? Sine squared, which if you remember anything about these, you might remember that that kind has to do with sine squared plus cosine squared equals 1. And so that kind is always just replaced with like, oh, that one's just cosine squared. All right, so that's a conjugate. Here's a much simpler one that has a conjugate. Could I multiply this by its conjugate? Yeah, if I knew what the conjugate of 1 plus x is, it's what? Don't overthink this. It's 1 minus x. Okay. So here's a complex number. What's its conjugate? If I define this as z, z is going to be my complex number. Then what's z hat? No, that's actually not hat. There is actually one that looks like a hat. But this is z with a line over it. I can't remember what it's called. Line over z is what I'll call it. Don't overthink it. It means conjugate of it. So what do you think it is? 1 minus 3i. That's all there is to it. And why would this matter? Well, because if you multiply two conjugates, good things happen. 1 plus 3i and 1 minus 3i. I'd like you to actually multiply it out and see what happens. Multiply those two conjugates out. See what happens. It's not like the answer just comes out to 1. Or does it? Just figure it out. All right, you should have had the first, which would be 1. Outside and inside cancel. Cool, that works out nice. That's one of the things that's cool about conjugates. And then the lasts make 3 times 3, and it's negative 9, and then I times I is I squared. And anytime you see an I squared, you can replace it with a negative 1, and then it's 1 minus 9 times negative 1, which means 1 plus 9, which makes 10. Do you get that the I went away when we did that? That's kind of cool. All right, last thing I have to teach you is you are not allowed to have square roots on the bottom. Do you remember me having a brief conversation with you about how that's called an irrational? So no, I'm wrong. That is called, we have to do something called rationalize the denominator because we have an irrational in the denominator. Math is fussy on what you divide by. Like, for instance, you just can't divide by 0. You get error, no solution, can't do it. And you can divide by negative numbers just fine, but you can't divide by an irrational number. Why? Because think about this. It's a decimal that goes on forever. How are you going to divide by something when you can't ever stop writing it? Get what I'm saying? And it's not only a decimal that goes on forever, it never repeats. Now, if it was like a decimal like 1/3, which it goes on but it repeats forever, then you could just write it like this, and 1 divided by 1/3 is no big deal. But 1 divided by a decimal that goes on and on and on and never repeats causes a problem for math. So you're not supposed to leave. Now, we've let you do it all through the whole trig unit because it was so much easier to just leave it alone, and because in the AP tests, they don't make you rationalize denominators. But in the complex number system, it's a really big deal that you cannot have that. Why? Because you have an I in the denominator. It's kind of like You can't divide by strange things. I is kind of a strange thing. In fact, I is even a square root. And so it makes it an irrational number. And you can't have an irrational number in the denominator. So how would I fix that? It's really simple. I just have to get that I out of the denominator. So I multiply the top and the bottom by, take a guess. Just an I would do it. No need to do a conjugate here because it's not like 1 plus something. So then this becomes 3i squared, which is the same as negative 3. And the top becomes I. And is that better? Yeah, because you can divide by negative 3. Would you please make this conjugate? No, not conjugate, sorry. Make this number rationalized so that you don't have i's in the denominator. Pause for a second, let me give that a try. So what'd you multiply the top and bottom by? Just I? No, can't do that. I think you don't mean just I. I can believe I over I. Okay, maybe we just weren't communicating there. Okay, so now I can multiply the top and the bottom by I. That's legal because this is equal to 1, and you can always multiply by 1. Now 2 times I is 2i, and on the bottom I have I squared, which makes, what's that really? Negative 1. So now it's 2i divided by negative 1, which makes it negative 2i. You can do that with any, even square root. Would you rationalize this one, please? Make it so it's not got a irrational denominator. Want to rationalize this. Okay, so you're going to multiply by root 3 and root 3. And that makes the top root 3. Simple. Bottom is root 3 times root 3, which makes square root of 9, which is 3. Cool. There it is. It's equal to the original, but better, because it doesn't have a square root in the denominator. All right, so final, the big piece de resistance. How about we make it this even more complicated? That has issues. It's got 2 issues with the denominator. Number 1, it's got an I in it. Number 2, it's got a square root in it. And I also is a square root, so it's got like all kinds of issues. But you can fix it by multiplying by, take a wild guess. Conjugate of the, not the whole thing, the conjugate of the denominator. All right, so then this would be 1 minus I root 2. Now go ahead, multiply that out. The top is just like it seems. It's 1 times that, so it's that. Bottom, it's a little more complicated. I'll do it in blue here. First 1. Outside inside cancel. Those conjugates are so nice for that. Then it's just the lasts. Careful with the negative. Negative I squared. And what's root 2 times root 2? Root 4, which is really, what's square root of 4? 2. And then you can replace the I squared part with negative 1. So that makes it 1 plus 2, which makes, look at how nice that cleaned up. 3. Raise your hand if you got a 3 in the denominator. Awesome. Then you understand the beginnings of complex numbers. So your assignment is arrow down to right here where it says assignment day 1. We're going to do this page, and I think 1 page of these is enough. You may skip this page. Then we're going to do a few of these, and they're so simple. Like, let me do number 11 with you. What is the square root of negative 49? 7i. That's it. So how is that even an issue? Because sometimes they put the negatives underneath the square root and multiply them together. So just you got to be careful with the order of operations. So you start on the inside, right? So we start on the inside here, and what's negative 25 times negative 4? And then you take the square root of that. So sometimes they come out imaginary, sometimes they don't. All right. On this page, we're doing those. Here's the simple thing. Up to here, this is the last page of it. You're just going to do the evens. And you get to skip the second page. So just the evens. Notice that's just like 2 questions here. All right. Now, what is this I to the 6th business? My reminder for you, you did this in higher algebra, is you make it into a whole bunch of I squareds. Because you know what I squared is, right? You get I squared times I squared times I squared makes I to the 6th. And you know what I squared is. What is I squared? Negative 1. So then you got negative 1 times negative 1 times negative 1, and that's all you have to do. So what do you got with the 26th? Are you kidding me? Yeah, you have to figure out, and you'll quickly develop a pattern, and you'll be like, oh, so it's really I squared a whole bunch of times. How many times? And then each I squared is a negative 1. So anyway. All right, so you're doing the evens. Remember, it stops right there. As soon as you go past that, it says day 2 kind of subtly over here. So you're into the next day's assignment, so don't go that far. So go up to here. Phone, backpack. I'm almost done, but I'm not. All right. So remember, it's only evens, but number 8's an even, but you get to skip this whole page. Remember? So make sure you skip this page. Now, if you want extra practice, you are welcome to do extra practice. There's plenty of problems there if you're not awesome at this, you want to practice them. All right. So that's it for today. Nice, easy one.